This is Physical Science 1, Chapter 3, Part 1 on motion, acceleration, and forces. In this portion of the video lecture, we will be discussing motion. So, how do we know that something is actually moving? We don't always need to see something to move to know that motion necessarily has taken place. From the image that you can see on your screen here, you can tell that the bicycler is moving, even though it is a still framed picture. Now, why can you tell that he's in motion? Well, that's because the background in compared to the bicyclist is blurry. So we know that something is moving because in our visual observation, we can notice that the background is changing. So in order to understand motion, we have to understand what a reference point is. When we talk about motion and position and a frame of reference, that reference point is needed to determine the position of an object. So then we know that motion is occurring if an object changes its position relative to that reference point. So either the background is changing in relative to that object, whether it be a person or whatever, but we need that frame of reference so we know that the object is what is moving and not ourselves. So motion is really relative. The frame of reference really will kind of depend on the motion of an object. So you can talk about motion in the classroom, so where you are, your immediate position. You can talk about the frame of reference for the town of Casson, the state of Minnesota, or a frame of reference can really be the whole world or our galaxy or the entire universe. Motion is occurring all of the time. Technically, because the earth is rotating and revolving around the sun, even when you are sitting in a position that you think you are still, technically you are still moving. But remember, in order to see motion, we need to have that frame of reference or reference point. So when we talk about motion, it's important to distinguish between distance and displacement. Distance is how far an object has moved. And remember, since we are in science class, we will use the metric SI system. We will be measuring in centimeters, meters, or kilometers. And displacement is both the distance and direction of an object's change in position from the starting point. Displacement does not always equal distance. Now, as you can see here, we have a runner maybe practicing sprints or whatever he's doing. So the distance that he has traveled, he went from the start line up to the finish line, which was 50 meters, and then looped around and came back and ended up at the 20-meter line. So he has traveled a total distance of 80 meters. However, his displacement, he is only 20 meters north of the starting line. So you'll notice that the distance traveled in this case is much longer than the displacement. So your displacement essentially is how far you are from the starting point. Your distance is the total amount that that object has moved. So we look at displacement as a vector because displacement has both distance and direction. So vectors are quantities that are specified by two things at the same time. In this case, both size and direction. Since we're talking about motion, we're going to need to talk about speed. If things are moving in time, they will have a certain speed. So speed is the distance an object travels per unit of time. For our purposes here in class, we will be measuring most things in either meters per second or centimeters per second. Remember, a rate is any change over time. So distance is the change in position, and the speed is the rate at which that distance is traveled or the rate of change in position. So we can calculate speed, and we need three things in order to do that. You need a distance, which will be in meters most likely, time in seconds, and then you'll need a speed. If you want to figure, if you know how long you've gone and how far you've gone, you can calculate your speed by taking distance divided by time. If you know how far you've traveled, you can take your you can also calculate the time that it takes to get there, knowing your distance and speed. And you can calculate how far you've gone if you know how fast you've been going and how long it's been taking you to go there. So we can take that speed equation and mix it around for any one of the three variables. Just to give you some idea of speed in units for the metric system, something that's very fast, like a rocket escaping the Earth's atmosphere, that would be 11.2 kilometers per second. A kilometer, remember, is 1,000 meters, so that's a very fast speed. General highway traveling speed is about 100 kilometers an hour. And very slow speeds would be something like the geological plate movements that are going at maybe centimeters per year. We can take a look at a couple of different types of speed when we look at motion of objects. An instantaneous speed is the speed of an object at a single instant of time. A very easy way to figure that out is looking at your car speedometer. So that'll measure how fast you are going at that very second that you glance at the speedometer. However, speed is rarely constant. In your daily travels, going from point A, your house, let's say from point B to school here, you will not be able to travel at the same speed. You'll probably have a stop sign or a yield sign, or maybe you'll have to slow down for traffic. A better way of taking a look at speed is the average speed. So when we, for example, calculate speed, we are taking the average. So we're taking the total distance traveled divided by the total time traveled. So this will help you describe speed of motion when the speed is changing. So on the graph below here, speed changing over a distance. This could be your drive to school, for example. So you start from your driveway at 0 kilometers per hour, and you get up to and gaining speed to the first hill. You have to slow down, going a little bit. You're going to go back downhill. Then you have to stop for a red light, so your speed goes back to 0. And you accelerate, and then you kind of stay at a constant speed until you get to the school building. So an average speed would be the total distance divided by the total time. We also have to take into account the velocity of an object. A lot of people use speed and velocity interchangeably, but they do mean different things. Velocity is the speed of an object plus its direction of motion. So objects can have different velocities if they are moving at different speeds or different directions. So two cars starting from the same starting line, let's say in a drag race. So one can have a different velocity than the other if it's traveling at a slower speed as they head to the finish line. And if in the second drag race, one of the racers accidentally has their car in reverse, they could be at the same velocity as the other car, but they would, or same speed as the other car, but they would be going different velocities because one of the drivers would be traveling in a different direction. We are going to take a look at graphing motion a lot with some of our hands-on activities that we'll be doing in class. But the motion of an object over a period of time can be shown on a very easy distance time graph. This will be a line graph. Again, we're going independent versus dependent variable. So the distance on a distance time graph is going to be plotted along the vertical axis or the y-axis. And the time is going to be plotted along the horizontal axis of the graph, or the x-axis. So in a distance versus time graph, your time is your independent variable because time does not change. 1 second is 1 second is 1 second. Same thing for an hour or a month or a year. And the distance is going to be your dependent variable. So the distance traveled will change over time. Remember, all graphs have to have a scale that covers the range of numbers to be plotted. So we can calculate the speed of an object using a distance versus time graph, and the speed would be the slope of your graph. So the slope, remember from math class, is your rate of change between 2 points, or how steep the line is. So your rise over run is going to be the slope, and on a distance versus time graph, the slope is going to equal the speed of the object. The steeper the line, the faster the speed. This has been Physical Science 1, Chapter 3, Part 1 on motion.